Assalamualaikum warahmatullahi ta'ala wabarakatuh, and a very good morning to everyone. So this is your first video lecture for subject Advanced Thermodynamics MME6154. I am your first lecturer for this course. My name is Dr. Izzatul. Okay, so in week 1, I will be the one who will be delivering the lecture for Advanced Thermodynamics, which includes Chapter 1, Introduction of Thermodynamics, Chapter 2, Energy Transfer and General Energy Analysis, and also Chapter 3, Properties of Pure Substances. Okay, so as you already know in your academic schedule, we are going to conduct the lecture on 20th November, 21st November, and 22nd November. Okay, for your information, I will delivering my lecture by uploading YouTube videos like this. For example, like this video. Okay, I will upload the videos before these dates, so you can watch the video. I think in almost in total around 7 or 8 videos. Then you can watch the videos based on your own time. Okay, however, even though you can watch the video based on your own free time, you have to watch all videos before 21st November and 22nd November. Why is that? Because I will assign you an assignment, okay, one assignment for week 1, okay, and the submission deadline will be 21st November, 11:59 p.m. Okay, for first assignment, it will included the content will be on chapter 1 and chapter 2. So you need to watch all videos, these two videos, okay, for regarding chapter 1 and chapter 2 before 21st November 2020, 11:59 p.m. Okay, you have to submit your assignment before this date, 21st November, 11:59 p.m. Okay, and then on chapter 3, you have to watch all videos for chapter 3 before 22nd November, 11:59 p.m. because I will assign you one quiz and the submission deadline is on 22nd November 2020, 11:59 p.m. Okay, so all questions and the submission will be conducting through Google Classroom. Okay, in my YouTube channel, there is a video on how to utilize or how to use Google Classroom. Then you can watch the videos, okay, and submit your assignment and quiz through Google Classroom. Please take note that you have to use full name for your account on Google Classroom. Okay. Then submit before deadline. Late submission equal to 0. Okay, I am very strict on the submission date. So you need to submit on time. Okay, so if first assignment, the deadline will be 21st November 2020, 11:59 p.m. If you submit on 12, okay, then 12 a.m., then it is considered 0 already. Okay, similar to quiz 1. Okay, and then please write your name, full name and student ID at the front page of any submission. Alright, so this is the introduction for week 1, which will be conducted by me, okay, chapter 1 until chapter 3. Okay, after we finish week 1, these 3 days, you will be continued with chapter 4 to chapter 6, and the lectures will be delivered by Dr. Yusri, okay, for second week. Okay, on chapter 4, you will learn on laws of thermodynamics. Chapter 5, the second law of thermodynamics, entropy. Chapter 6, operating principles and performance parameters of thermodynamic cycle. Okay, after chapter 4, chapter 5, and chapter 6 learned, okay, and the lecture will be given by Dr. Yusri, we will conduct test 1. Okay, test 1. It's like a midterm examination. Okay, after chapter 6, and the contents are from chapter 1 until chapter 6. Okay, so here we have midterm examination. Okay, test 1. Alright, then in week 3, okay, the lecture will be continued by Dr. Nasrul Hadi. Okay, he will giving a lecture on chapter 7 and chapter 8, okay, on week 3, and then continue with chapter 9 to chapter 11, and the lecture will be delivered by Dr. Sudaka on week 4. Okay. For your information, as written here, you have to complete a thermodynamic design project on chapter 11. Okay, I think Dr. Sudaka later will explain more on this project. Okay, so after finish chapter 7, 8, 9, 10, and 11, okay, we will conduct another test, okay, test 2 or equal to the final examination, okay, and the contents included chapter 7 until chapter 11. Okay, later, maybe Dr. Nasrul and Dr. Sudaka will explain more on test 2. Alright, so let's start. Okay, in chapter 1, okay, in chapter 1, you will be learn on thermodynamics and energy, specific heat and latent heat, a note on dimension unit, closed and open system, properties of system state, state and equilibrium, pressure and temperature, work, heat and energy, kinetics, potential and internal energy. I believe most of you, okay, all of you, I believe, already learned all of these subtopics. However, we will recap on these subtopics on chapter 1. Okay, let's start. Now, let's see the definition of thermodynamics. What is thermodynamics? Thermodynamics is a science of energy, and it comes from the Greek words. Okay, therm was defined as heat, and also dynamis means power. Okay, so the description is it is the early efforts to convert heat into power. Energy is viewed as an ability to cause changes. Now, conservation of energy principle, it is actually a fundamental laws of nature. Okay, what is the meaning of fundamental laws of nature? During an interaction, energy can change form from one form to another form, but the total amount of energy remains constant. Okay, so please remember, energy can change form. However, it cannot be created or it cannot be destroyed, and the total amount of energy remains constant. Okay, so this laws is actually equal to the first law of thermodynamics. Energy cannot be created or destroyed, and the total amount of energy remains constant. It only can change form from one form to another form. For example, let's see this situation. Okay, we have potential energy equal to 10 units and the kinetic energy equal to 0. Okay, for this rock at the edge of a mountain. Okay, we have potential energy 10 units, kinetic energy 0. But then when this rock falls down, okay, the energy is changed. Okay, from 10 units of potential energy change to 7 units to potential energy and 3 units of kinetic energy. You can see that the total amount of energy is the same. However, the form of energy change. Okay. And another example, we have this sumo person. Okay. Energy in, okay, maybe energy in terms of food that he ate, okay, during lunch, it is 5 units, and then he already have energy storage 1 unit. Then he can do exercise, okay, do sumo with 4 units energy. Okay, so it's actually the same, 5 unit, 1 unit and 4 unit. Okay, this is the conservation energy for the human body. So what you need to understand in this slide is to remember the first law of thermodynamics means energy can change form. However, energy cannot be created or destroyed, and the total amount of energy remains constant. Okay, actually, it can be written like in this equation, energy balance equation, E in minus E out equal to delta E. Okay, now let's see more examples of first law of thermodynamics. Okay, we have a work shaft done on an adiabatic system is equal to the increase in the energy of the system. Okay, here you can see it is the same. Okay, what is adiabatic? Okay, later you will learn more on the types of system. Okay, here they use adiabatic system. Okay, adiabatic system is a process one that occurs without transfer of heat or matter between a thermodynamic system and its surrounding. In an adiabatic process, energy is transferred to its surrounding only as work. Okay. Okay. Another example, we have this situation. Okay. Q in equal to 15 kilojoule, delta E equal to 12 kilojoule, and Q out equal to 3 joule. Okay, you can see that the total amount of energy is actually the same. Okay, in the absence of any work interaction, the energy change of a system is equal to the net heat transfer. Another example, you have a potato, okay, in an microwave. Okay, Q in equal to 5 kilojoule, then delta E equal to 5 kilojoule. The increase in the energy of a potato in an oven is equal to the amount of heat transferred to it. Alright. So now let's see an applications of this first law of thermodynamics. For example, for human, we have heart pumping blood to all parts of the human body. Various energy conversions occur in trillions of body cells. Body heat generated is constantly rejected to the environment. So we have human comfort, the rate of this metabolic heat rejection. Okay, to control this and to get the human comfort, we can control it by adjusting our clothing to environmental conditions. Okay, and another example, such as solar hot water systems, like shown in this figure. Okay, another applications of thermodynamics, we have electric or gas range. Okay, like for example, air conditioner, refrigerator, shower or water heater, or the more complicated and big applications that use thermodynamics, laws of thermodynamics, such as rockets, okay, jet engine, gas turbine, and also internal combustion engine. Okay, so you have learned the definition of first law of thermodynamics, and you already see some of its applications using first law of thermodynamics. Okay, now let's see what are the approach on thermodynamics and energy. Okay, as we already learned, thermodynamics is a science that deals with energy transformations and the relationships between properties of system. Okay, property, it is any observable characteristic of a system, and then system, any identifiable collection of matter. Okay, now what are the approaches in thermodynamics? We actually have two approaches. First, macroscopic approach, and the second, microscopic approach. In macroscopic approach, observations and measurement of properties on a large scale basis. Measurements are made on the large scale, thus relative to the microscopic behavior of the substance, matter or material, and it is also known as classical thermodynamics. And then we have microscopic approach. It is observations to postulate behavior at the particle or molecular scale. Okay, it uses mathematical calculations on the molecular scale to determine properties from statistical averaging of the behavior of individual particles. Okay, averaging of the behavior of individual particles. Okay, it is also known as statistical thermodynamics. Okay, guys, please remember we have two approaches in thermodynamics. One is macroscopic, known as classical thermodynamics, and another one microscopic, known as statistical thermodynamics. Okay, let's see what is the definition of specific heat and latent heat. Specific heat, energy needed to raise of a unit mass of a substance by 1 degree Celsius. Specific heat at a constant volume. Okay, The symbol is CV, small CV. Specific heat at constant pressure, the symbol is CP. Okay, I believe all of you must already learn what is the definition of specific heat and latent heat. So here we just need to recap on this topic. Okay, so latent heat, what is latent heat? Energy absorbed. Okay, it's different with specific heat. Okay, latent heat, energy absorbed by or released from a substance during a phase change from a gas to a liquid or a solid or vice versa. Okay, then for example shown in this graph, we have solid phase, liquid phase and also gas phase. Okay, from solid phase to liquid phase, we have a phase change from solid to liquid. Latent heat here is absorbed. Okay, absorbed. Okay. And then from liquid phase to gas phase, latent heat is released. Okay. Now, a note on dimensions and unit. Dimensions. Okay, what is dimension? It is a characteristics of a physical quantity. Primary dimension. Okay, fundamental of dimension which is not come from any derivation. Okay, you cannot get this property or dimension from any derivation. Okay, mass equal to mass. M, length, temperature. Secondary dimension. Dimension that come from the derivation of primary dimension. Velocity. Okay. Velocity equal to meter per second. Okay. So we get velocity dimension from derivation of primary dimension, which is meter and second. Energy, then volume. Okay. Units is the arbitrary magnitude that is assigned to the dimension. Okay, here I list down several important SI systems of unit that you usually will found in thermodynamics and also fluid mechanics. Okay, so Newton equal to kilogram meter per second squared. Okay, of course, this is the secondary dimension because Newton is derived from this primary dimension. Okay, and then joule, Newton meter, kilogram meter squared over second squared, and then we have power watt, okay, joule over second, and then we have pressure, Pascal, Newton over meter squared. You guys need to at least remember this SI system of units because it is very important in thermodynamics, especially in calculation questions. Okay, so in these topics, you learn about the latent heat and also specific heat. Okay, specific heat. Okay, so let's continue. Now, let's learn on thermodynamic system. First, we need to know what system means, the definition of system. And in thermodynamics, how many systems, type of system is separated. Okay, so now what is system? System is actually a quantity of matter or a region in space upon which attention is concentrated in the analysis of a problem. Actually, system is anything that you can think of. For example, a system of a piston. Okay, or to if you think bigger, for example, a system of a car engine. Okay, so the attention is concentrated in the analysis of a problem. For example, you have this system. For example, this is a car piston system. Then the analysis of a problem is concentrated, is focusing on this system only. Okay, it is a quantity of matter or a region in space, okay, upon which attention is concentrated in the analysis of problem. Everything external to the system, everything external is called the surroundings or the environment. The system is separated from the surrounding by the system boundary. Okay, system separated by the surrounding with system boundary. And this boundary may be fixed or moving. Okay, we have either fixed boundary or moving boundary or imaginary boundary. Actually, we have another one, imaginary boundary, okay, where you cannot see the real boundary between that separate the system and the surrounding. It is imaginary. Okay, a system and its surroundings together comprise a universe. So this is the universe of a system. Just now, I give you an example, a system of a piston. So this is a universe of a piston system. Okay. Now, how many types of thermodynamic systems? Actually, we have three classes of system. We have open, closed, and another one, isolated system. Open, closed, and isolated system. Let's see the first system, first class, closed system. Closed system, also known as control mass, means you can control the mass. Okay? Mass will be fixed. Alright. So let's see. System of a fixed mass. Okay? Constant mass, where no mass transfer across the system boundary. Okay, let's see this system. No mass transfer happen through the system boundary from surrounding into the system. No mass transfer. That is why it is known as control mass. You can control the value of mass of this system. Means it is fixed. Okay, system of a fixed mass. Please remember. However, energy transfer in the form of heat and work into or out of the system may happen, and the volume does not have to be fixed. Okay, energy in, energy out can happen. Okay, energy transfer can happen through the system boundary. Okay, let's see this example of a piston. Okay, we have moving boundary and also fixed boundary. Okay, when you apply heat, okay, so you have fixed boundary that separate system and the surrounding. Okay, you have fixed boundary, and you also have the moving boundary. When this piston is heated, okay, the moving boundary is moved. The boundary is moved by the moving boundary. Okay, from 2 kilo 1 meter cubic to 2 kilo to 3 meter cubic. See, volume does not have to be fixed. Okay, that is why 1 meter cubic becomes 3 meter cubic. Okay, so now in closed system, what you need to understand the definition of closed system. It is known as control mass, where mass transfer cannot happen. Okay, through system boundary, however, energy transfer can happen, and the volume does not have to be fixed. Usually, this kind of questions, definition questions of closed system, open system, and also isolated system will be asked in your examination. Okay, now you already understand the definition of closed system. Let's see open system. Open system is also known as control volume. Okay, means volume is controlled. Okay, volume is controlled. Let's see. Matter and energy can cross the boundary of a control volume system. Okay, of a open system. Okay, let's see this system. We have mass in, mass out, energy in and energy out. Means that matter and energy both can crosses the system boundary. Most of the engineering devices are generally an open system. For example, air compressor in which air enters at low pressure and leaves at high pressure, and there are energy transfers across the boundary. Usually encloses a device that involves mass flow such as compressor, turbine and nozzle. So this is the difference between open system and closed system. Closed system, no mass transfer, energy can transfer, volume does not have to be fixed. However, in open system, both mass and energy can cross the boundary. However, volume is fixed. Volume is controlled. Okay, I already summarized it in here. Okay, system between closed system and open system, okay, known as control mass system, known as control volume system. In closed system, mass in the system is fixed and cannot enter or exit. Energy can enter or exit. Volume is not fixed. Okay, in open system, those mass and energy can flow in and out, but the volume remains constant. Okay, remember, control volume means volume is constant. Control mass means mass is fixed, mass is constant. Okay, in closed system, there are two types of boundary in closed system, moving boundary and fixed boundary. However, in open system, we have boundary for control volume are called control surface, and this control volume can be fixed, moving, real, or imaginary boundary. Okay, so if you ask in the examination, what are the difference between closed system and open system, you should write like this. Okay, like in this table. Alright. These are some of the example of open system or known as control volume. A control volume with real and imaginary boundaries. Okay, we have real boundary, okay, a nozzle, and then imaginary boundary. We put this imaginary boundary for us to do a calculation for this particular mass, okay, for this particular matter of the system. Okay, that is why there is a imaginary boundary. Okay, and then a control volume with fixed and moving boundaries. Okay, we learned this before. We have fixed boundary and also moving boundary. And then an open system with one inlet and one exit. Okay, for example, water heater. Alright. Now, the last class of system is called as isolated system. What is isolated system? Okay, isolated system where no interaction between the system and the surroundings. No interaction happen. It is of fixed mass and energy, and there is no mass or energy transfer across the system boundary. Mass is fixed, energy also fixed, and no mass transfer, no energy transfer happens across the system boundary. So that is the definition of isolated system. So now you already understand the difference between closed, open systems and the definition of isolated system. Now, for subtopic 1.5, properties of system states. Okay, previously we have learned the properties of a system, where the characteristic of that system itself, okay, it explains the characteristics of the system itself. We know some of the properties available, for example, pressure, temperature, volume, or mass. And these properties are known, I mean, it's familiar to us. However, these properties can be extended to less familiar one, such as viscosity. Okay, we have elasticity and other less familiar properties such as velocity. Okay, so now thermodynamic properties can be divided into two general classes. Okay, actually we have intensive properties and also extensive properties. What are these properties? Okay, in intensive properties, okay, it is independent of the amount of mass. Okay, for example, we have temperature, pressure, and density are the example of the intensive properties. It is independent of the amount of mass. Okay, lowercase letters are used to denote except pressure P and temperature T. Okay, however, in extensive properties, the value of an extensive property varies directly with the mass. Okay, means that it is a value that depend on the size or the extent of the system. If a quantity of matter in a given state is divided into two equal parts, each part will have the same value of intensive property as the original and half the value of the extensive property. Mass and total volume are the examples of the extensive properties. Okay, uppercase letters are used to denote except for mass, and extensive properties per unit mass is called specific properties. Okay, specific properties is actually per unit mass. Okay, for example, specific volume. Small v equal to V volume over mass. Okay, specific volume denotes with small v equal to volume large V over mass. Okay, we also have specific gravity. Okay, it's the same. Okay, it is per unit mass. All right. Criterion to differentiate intensive and extensive properties. Okay, let's see here. We have these properties. If you divide into two parts, okay, you can written it like this. For extensive properties, half mass, and half volume, half volume. Okay, however, for intensive properties, it is the same. Okay. Now, density is equal to mass per unit volume. Okay, you already know about this. Rho equal to mass over V, kilogram per meter cubic. The reciprocal of density is the specific volume. Okay. Specific volume equal to V volume per unit mass, or equal to 1 over rho, meter cubic per kilogram. How about specific gravity? Sometimes the density of a substance is given relative to the density of a well-known substance. Then it is called specific gravity or relative density. Specific gravity or relative density is actually equal to the ratio of the density of a substance to the density of some standard substance at a specified temperature. Okay, sometimes we don't know the density of a something, of a particular matter. So what we do is we compare the density with the density of a known or standard substance at a specified temperature.